Hi guys, today we are learning our last chapter 9 lesson 9.4 called independent and dependent variables. First, you're going to figure out what is an independent versus a dependent event and how do I find independent, how do I find dependent. So it's a different type of, we're not really looking at the probability now, we're looking at the type of event we're looking for. So let's look to learn on textbook page 406. What is an independent event and what is a dependent event? We'll pause the video while you look to learn. All right, so here are some notes. It does say take notes in big bold letters. Two events are independent if the occurrence of one event does not affect the likelihood of the other event. So one thing happening doesn't affect another thing happening. Whereas two events are dependent if the occurrence of one event does affect the likelihood of another. So independent, two separate events, doesn't affect each other. Dependent, one thing affects the other. So for example, rolling a dice and spinning a spinner, these are two different things. They're not going to affect another. But if I'm drawing names to go first in my public speaking class, well, once I call one person, it's going to affect who I call next because I can't call that same person again. That's a dependent event. So independent, two things that are done, they don't affect each other. Dependent, two things are done, one affects the other. And we'll definitely look at some examples. So tell whether the events are independent or dependent. Explain. You roll a dice and get a 5, and then roll it again and get a 2. So when I roll my dice, does getting a 5 affect how many numbers are on the dice? No, there's still 6 numbers when I go to roll the dice again. So these would be considered independent. Because the probability of getting a 5 is a 1 out of 6 chance. The probability of getting a 2 is a 1 out of 6 chance. There's still 6 numbers on the dice every time I roll. They don't affect each other. Miss Hine chooses one student to go to the office. So I stand them up, I send one student to the office. Then, while that student's gone, I need to choose another student to go help Miss Stack with something. So let's say I choose 1 out of 30 students to go to the office. This is for the office. Then I need to choose a student to go see Miss Stack. Well, I'm going to choose one student out of, well, I lost a student in the office, so now I only have 29 students left. This would be considered a dependent event because the amount of people I had changed. So again, the first time it was independent because I still had 6 numbers on the dice. That didn't change. Whereas the second time, I lost a student because they were in the office. So again, independent if they don't affect each other, dependent if they do. Go ahead and you try this one. You're going to determine, is the event independent or is it dependent? We'll pause the video while you try it. Here are the correct answers. So when I look here, independent are the first two because rolling a number cube or a dice, you're always going to have out of 6. Flipping a coin, you're always going to have 2 sides to the coin. You can't get rid of one of the sides. Number 3 is dependent, and it's dependent because when I look here, it says you keep the marble, which means on the first draw, you had 8 marbles. But on the second draw, you only had 7 marbles. Number 4 here says you put the marble back, which means both times you have 8 marbles to pick from. You didn't change the amount of marbles in the bag because you put it back before you drew again. All right, so let's go ahead and continue on. I think we have another practice here. So go ahead and try these 4 in your notebook. Again, you're stating, is this independent or dependent? We'll pause the video while you work. And here are the correct answers to this. Try it. So the first one, spinning your spinner, the numbers on the spinner don't change. The second one is dependent because you vote for president, you can't vote for that person for vice president, so you have to vote for someone else. Same thing with keeping the tile. You can't pick out the tile that you just picked if you kept it, so your probability is dependent. And last but not least, putting the tile back makes me still have 20 game tiles in the bag, so that is independent. All right, so now we're going to learn how to calculate calculate a probability of 2 events happening if it's an independent event. So look on textbook page 406 and 407 to figure out how do you calculate independent events probability. So in the past couple of days, you learned the probability of one thing happening. But now we're going to find the probability of 2 separate events happening. And we do that by multiplying the 2 probabilities together. So you find the probability of the first event happening times the probability of the second event happening. So again, this is the probability of 2 events, both events happening. Probability of rolling a 7 and then rolling a 2. Let's look at an example here. So we are flipping a coin and rolling a dice. Find the probability of both events happening. So what we do here is flipping heads. What's the probability if I flip a coin that I'm going to flip heads? Well, 1 out of 2, because we know that there's 2 sides to a coin. What's the probability of rolling a 3 on a number dice? Well, 1 out of 6, because there's 6 numbers on a dice and there's 1 3. To find the probability of both of these things happening, I'm going to multiply them together. 1 times 1 is 1, and 2 times 6 is 12. So there's a 1 in 12 possibility that if I flip a coin and roll a dice at the same time, that I'm going to get a heads and a 3. So what I did there is you find the probability of each of them, and then you multiply them together. The probability of flipping tails and rolling an even number. Well, the probability of flipping tails is 1 out of 2. And the probability of rolling an even number. Well, there's 3 even numbers on the dice out of 6 numbers, and I multiply them together. 1 times 3 is 3, and 2 times 6 is 12. Yes, you do need to simplify. So 3/12 is going to simplify down to 1/4. Here we have not flipping tails and not rolling a 4. Well, the probability of not flipping tails, the only other option is heads. So that's also going to be 1/2 times the probability of not rolling a 4. Well, I could roll a 5, a 6, a 1, 2, or 3. There's 5 options out of 6 numbers on a dice. I multiply those together to get my final answer of 5/12 chance. So again, in this one, we're finding the probability of something and something else. 2 events happening. Go ahead and you try it with these 2. We'll pause the video while you work. And here are your correct answers to the you try. So for this first one, the probability of flipping 1 heads and 1 tails, well, the 1 heads is a 1/2 chance, and the tails is a 1/2 chance. Multiply them together to get 1/4. Flipping a coin and rolling a dice, the flipping a coin, flipping tails is 1/2. A number less than 5 is 4/6. Times them together to get 4/12, but you have to simplify 1/3. All right, so that's how you find independent events. What's different about dependent events? Use textbook page 408 to look at that example. How do you do it? So dependent events are very similar. You are still going to multiply, but you multiply the probability of the first event, just like normal. The second event, you need to figure out what is the probability after the first event happens. Then you multiply them together. We'll look at some examples. But again, it's the probability of A times the probability of B after A happens. So there's one extra step in there. The drawer contains 18 spoons and 12 forks. You randomly pick 2 utensils. What's the probability that both are spoons? Well, let's first figure out the probability of the first one being a spoon. What's the probability we pull out a spoon? Well, 18 out of 30 total utensils. This again is the probability of A. The probability of B after A happened. So we pulled out 1 spoon. What's the probability that the second utensil we grab is also a spoon? How many spoons are left because the first one's already a spoon? Well, now there's 17 spoons left out of 29 utensils. You can multiply them together and you end up getting 18 times 17 is 306 over 870. This can be simplified by dividing out a 2, and you get 153 out of 435. And that can't be simplified any further. So again, first you need to figure out the probability of the first thing happening. The second one, you can see I acted like I already pulled out a spoon and I had to recalculate how many utensils there were left to pick from. Go ahead and you try this next one. We'll pause the video while you work. And here are your correct answers to the you try. So for this first one, choosing the first red card, the probability was a 10 out of 16. The second red card, there's only 9 red cards left out of 15 total cards. Simplify that to 3/8. Here, the probability of a blue card is there's 4 blue cards out of 16 cards total. The probability of the next card being a yellow card. Well, there's still 2 yellow cards, but there's only 15 cards total. Multiply them and simplify down to 1/30. All right, you do have homework today. It is journal page 222, all. If you want extra practice, look on pages 409 through 411. Thanks.